Hi Kansas City, let's get started with some math. We are moving on to a new topic. We've been working on fractions and decimals, and we're going to start thinking about analyzing our data and what we see with some of our data sets. So for Just Know It today, I'm actually going to introduce some vocabulary that I just want you to know as we move forward. And the first one is line plots. We're going to be using line plots today, and I want you to just know that a line plot is a way to show our data on a number line, which you already know a number line. So here's an example of a line plot where we have under 0, we have a data of 1. Under 1, we have 3. We have a dot that represents 2, and then 3 on the point on the number line that represents 3. So when I talk about line plots today, just know that it's putting our data on a number line. And the second word I want you to know today is outlier. So on our line, our number line, I want you to know when we look at that line plot, that any numbers that are very different, so very much larger or smaller or away from the data set, those are called outliers, and we're going to look at those today. All right, so let's move on to figure it out. All right, for figure it out, I have this big dice here, and I'm going to throw it up in the air, and whatever lands on the side that you can see, we're going to plot on our chart. So we're going to keep track with tally marks, and we're also going to plot on our number line. So the first thing we need to do is make our number line. I already have here a number line ready for me, but you can just draw it at home if you have a piece of paper. I'm going to start with 1, because we know that on the dice is 1. So 1, 2, 3, 4, 5, 6, and we can just put 7 on there, although we know our dice doesn't have a number 7. So what we're going to do is I'm going to throw it up in the air. Whatever lands is going to be what we plot and keep track of. So here we go. 4. So we're going to put a tally for 4 and plot it there. 6. Tally. Okay, ready? 6 again. 1. 4. 6. Wow, another 6. 6 again. How is that possible? So many 6s. 3. 1. 4. 4. Let's do a spin throw. 5. And 3. Let's make that our last one. So take a look at what we made here. So you can see we kind of kept track up here with tallies, and if we needed to double check, we could go back and make sure our line plot was accurate. So we see we have 2, none for the number 2 on our dice, 2 for the number 3 on our dice, 4 in the number 4 spot, 5, and then 4 again. And we can see that the most common number here that we rolled was both 4 and 6. And then 5, we rolled 1, but we didn't roll any for 2 today. So that was just a little practice plotting numbers on our line plot as we used our dice. Let's move on to a different figure it out. For this figure it out, we're going to be looking at this data that we have here. So let's read what it says. Garden Club is growing daisies. They want to see what daisies' heights are. The outliers. Make a line plot. What are the outliers? This is kind of tricky because we don't have a number line yet. So let's get ready by doing our number line. So we read R, T, D, W. So we read it. Let's think about it. We're going to do that number line. Okay, and let's look at our scale. What numbers we think we should put on our scale. So we have 5.5, 6, 6.5, 6 3/4, 6 1/4, 6.5, 6, 6.5. It looks like our largest number is 6 3/4. So maybe we can make our whole number at the very end 7, because we know that will include that 6 3/4. And I'm thinking, what is the smallest number we have? Well, it looks like 5 1/2. So maybe we can make our smallest number on our scale 5. So now we have 5. Let's make that middle number 6, and let's fill in. So we know between 5 and 6 from our fraction work would be 5 1/2, and we know between 6 and 7 would be 6 1/2. And now if we want to get those quarters, we'll just add those. Okay, so we drew something to help us. So now we need to go through and think about plotting these numbers. So let's plot. And one thing to think about is as we plot, we want to cross off the ones that we've done so that we don't get confused and accidentally plot them multiple times, because then we'd be left with data that is not correct. So let's start here. 5 1/2, 6, 6 1/2, 6 3/4, 6 1/4, 6 1/2. Oh, I messed up. This doesn't go here. Whoopsie daisy. Let's cross that one out. That would be 5 3/4, 6 1/4. That's all part of figure it out. Sometimes you make mistakes. Okay, so we got 6 1/4, 6 1/2 again, 6 again, and 6 1/2 again. So what are the outliers here? What are the ones that are the furthest from the data set? It looks like this 5 1/2 is kind of far from the data set, although not like so wildly different, but it is different. Most of them are 6 or higher. And I don't think this one is pretty close. This is 6 3/4. That's not that different than 6 1/2. So I would say that 5 1/2 is probably our outlier in this data set. All right, let's move this on down to what's new. Well, I already sort of introduced what's new, but let's look at that learning target. I can represent and interpret data on line plots. Okay, so we already learned that line plots is using a number line, okay, to show our data set. And represent, so we're gonna show it. We're gonna show what it looks like. I'm gonna draw an eye there because that helps me remember to show it. And interpret. So that means we're going to be figuring it out. We're going to be looking at it and analyzing it. So I'm going to draw a think bubble here. So we're going to be thinking, what do we know from that data? And the data is going to be a collection of information about some topic, like the heights of the daisies in the garden. So I can represent or show and analyze a collection of information on a line plot, which is like a number line with information on it. Well, let's see what that looks like for today. Okay, for what's new today, grab your writing tool and paper or marker board to get started. And here is our first problem. Below is a line plot of the lengths of friendship bracelets Jessica made. 4 people want 6-inch bracelets. Does she have enough? So we're going to interpret this data that we have here. We read this. We're thinking. We're going to interpret. We're going to look at what we have. We don't really need to draw anything because it's already drawn for us, but we should write a sentence. So let's take a look. So we need 4 friendship bracelets at 6 inches each. Well, we have 1, 2, 3. So there's only 3 here. And so that tells us we don't have enough. She would need to make 4, or at least 1 more to make 4 6-inch bracelets. So no, she does not have enough 6-inch bracelets. She does have 6 1/4, so maybe she could convince somebody to use one of those, but she does not have enough 6-inch. And it looks like 5 over here is an outlier. It's kind of on its own way on this end of our line plot. Mrs. Latimer has been riding her bike to work. Below are the number of minutes it has taken her over the last 2 weeks. What scale could be used to make a line plot? Okay, let's do our RTDW. Read it. We're thinking about the scale. So from the smallest to the largest. Let's look at our numbers. So these are minutes. 20, 20 and a half, 20 and 21 and 3/4, 22, 20 and 3/4, 20 and a fourth, 20, 22, 21 and a fourth, and 20 and a half. So it looks like our smallest number might be 20. And it looks like our largest number, we got 21 and 3/4. It might be 21 and 3/4 looks like. Okay, so maybe we should make it 22. So let's do our scale. Scale equals 20 to 22. And let's read this one. Make a line plot and determine if there are any outliers. Okay, so we know our scale. So we got 20 and 22. So we got 21 in the middle, just like we saw today on our figure it out. So we had 20 and a half and 21 and a half. And so then we have our, so this would be 20 and 1/4, 20 and 3/4, 21 and a fourth, 21 and 3/4. Okay, so we got 20, 20 and a half, 21 and 3/4, 22. Oh, I don't even think I mentioned 22 up here. There's two 22s. Okay, wow, see? Sometimes you're making your scale and you might even miss it the way it's organized. So good to make sure we have included that one. 20 and 3/4, 20 and a fourth, 20 again, 22, 21 and a fourth, 20 and 1/2. I think we got it all. Okay. It doesn't really seem like there are any numbers that are wildly different. It seems like she's reading at a, or not reading it, biking at a pretty good pace. So let's say, no, there are no outliers. Everything is generally about the same amount of time. Nice work. Thanks for working to figure out those what's new problems with me. And I just thought it'd be fun for you to do a let's roll and plot on your own at home. So if you have dice, or you can go online and you can use the online web dice to roll it and kind of plot what numbers you get. And you can see I made a line plot here, a number line from 0 to 6, although you could do yours from 1 to 6 or whatever dice you are using. And then I thought it might be fun for you to ask your friends how many pets they have and make a line plot and analyze the data, interpret the data. Do you have any outliers? So you could see if there's any of your friends who have like 6 or 8 pets. Maybe they have a lot of fish or other animals at home that they take care of. Maybe they take care of all the stray cats on the street and they consider them their pets. Or maybe you have friends who don't have any pets at home, and so they might be an outlier if you have lots of friends who have some pets. So have fun with that and come up with your own questions to make your own line plots and analyze the data. It is time to say goodbye, and let's end with 2 firework high fives and a roller coaster and cool at the end. 2 fireworks, roller coaster, and cool, way cool at the end. Here we go. 1, 2, 3. Clap. Shh. Ah. Clap. Shh. Ah. Clickety, clackety, clickety, clackety, clickety, clackety, wee, wee, wee. Cool, way cool. Thanks for watching.